Hi everyone. In this video, I will be using transfer learning to train a model to do multiclass classification for computer vision. This is the second video in the series of my preparation work to take the Google Tensorflow Certificate. Do note that the certificate that I am preparing for is the one that is to end as of May 2024. If you haven't watched my first video, be sure to check it out where I cover more details on how to set up PyCharm. In this video, I will be coding on Google Colab instead of PyCharm, as personally I feel that it is easier to display and show intermediate workings instead, but the code should work in PyCharm as well. I have shared the link to the code in the description box so you may follow along. So first of all, what is transfer learning? According to Wikipedia, it is a technique in machine learning in which knowledge learned from a task is reused in order to boost performance on a related task. For example, for image classification, knowledge gained while learning to recognize cars could be applied when trying to recognize trucks. In other words, it is a model which has been trained by others which we will use to apply and solve our problem. In this case, it would be a computer vision problem of identifying a multi-class classification. Let's dive into the notebook to take a look. We will be covering a few key concepts that might be tested in the TensorFlow certificate. They are: loading data from a directory, using transfer learning to pre-train a model and freeze the layers, utilize dropout to prune the neurons, and lastly, to solve a multi-class classification problem where we will be using the rock, paper, scissors dataset. First off, we will load the libraries that we will be using. We import zip file and OS to manage the file directories when the data is loaded into the temporary memory. Next ones are the familiar functions that we will need to use from the TensorFlow library. You may notice that we have imported Inception v3, which is a convolutional neural network architecture from the Inception family. We will be using this as our pre-trained model. The next two from Matplotlib will be used to display charts and images. As per the first video, we will import SSL as well to resolve any certificate issues if you are running this code from the computer. In the next cell, we will download the rock, paper, scissors dataset. The train and test set are stored separately as zip files. Additionally, we will download the pre-trained weights of the Inception v3 model as well. We will load the weights into our model so that the model will use these pre-trained weights instead of training from scratch. Once they are downloaded, we will proceed to unzip and extract all the files and split them into different directories for training and test data. The test data will be used as validation data for our model later on. We can print to see how many images are in the training dataset and if there is any skewness in data. We will also inspect 2 images from each class to see how they are like. Great, there are 840 images in each class, so it is quite well balanced and the images show what we expected to be, which is rock, paper, and scissors. In the next cell, we will build the image data generator. This time, we will use the flow from directory method to augment the data as they are loaded into the directories which we have set previously. We indicate the target size to be 150 by 150, which is the size of the images, and set class mode to categorical as it is a multi-class problem. Now, let's run it. Great, the training and validation data set looks good. The code to pre-process the data is now complete. Now we will build the model by initializing the Inception v3 model. First, we will define the input shape and exclude the final layer by setting include top to false. Next, we will load the weights and freeze the layers by setting the layer trainable to false. We can also print the summary to have a sense of how the model looks like. As you can see, the model goes very deep and has many layers, reducing the image to a size of 3 by 3 at mixed 10 layer. As the model is trained on a multitude of data and ends up with a very convoluted image, we don't need so many layers to train for our dataset as it is a relatively simple one. So we will pick mixed 7 as our last layer from the Inception model, which gives us a nice 7 by 7 image, and we will build our own layers on top of the pre-trained model that we have. We will add a few layers and include a dropout, which will reduce the number of trained neurons from the previous layer. The final layer will have 3 neurons as there are 3 classes, and we will set the activation function to softmax. We can connect the pre-trained model and our final layers and inspect the architect of it via summary. Even with the few layers we added, the total number of parameters has increased, and we can see there are significantly more trainable parameters. Now we can compile and train the model. Note a difference between multiclass and binary classification is the loss argument under compile, where we will set the loss to be either categorical cross-entropy or sparse categorical entropy for multiclass classification. If the labels are one-hot encoded, we should use categorical cross-entropy. But if the labels are given as an integer value, we should use sparse categorical cross-entropy instead. We will train the model for 10 epochs and feed in the training and validation generators that we have created earlier into the model. I will skip the training of the model here. Once the model training is completed, we will plot the accuracy and loss charts as usual. And that's the end of this video. We have covered the key concepts of loading a dataset from a directory, using transfer learning and freezing the layers, employing dropouts, and training a model to do multi-class classification. Hope that it is useful to you as a reference. So, what are your thoughts on it? Feel free to comment in the comment box down below. If you liked this video and would like to see more content of this nature, please be sure to like and subscribe as well. Thanks for watching, and until next time.